Hi, everyone, and welcome to day three of TestMu Conference 2026. I'm Vaishali, Product Marketing Manager at TestMu AI, and I'll be your host for this session, Redefining Test Data Strategy in the Era of Generative AI. It's great to have you all here with us. Before we begin, a small ask. Let's share our takeaways on LinkedIn or X, tag us, and use the hashtag TestMuConf so others can be a part of the conversation too. And if you have any questions during the session, you can drop them in the Q&A box. We will take them up towards the end. Today we have Manideep Singireddy joining us for the session. Manideep is a senior manager and SDET architect with 13 plus years of experience transforming software quality through AI, intelligent automation, and scalable quality engineering. He specializes in AI driven testing, automation architecture, UI, API, mobile performance testing, and CI/CD across complex enterprise platforms. His automation strategies have delivered 40 to 50% gains in testing efficiency and helped reduce critical defects through shift left practices and intelligent automation. In this session, he'll share a practical framework for bringing generative AI into test data management, generating realistic data, masking sensitive information, surfacing edge cases, and show where AI helps, where human judgment still matters, and how to adopt it without breaking compliance. So, thank you so much for joining us, Manideep. The stage is all yours.
Thank you, Vaishali. Thank you. Thanks, everyone. Good morning, good afternoon, and good evening, everyone. Hi. Today, I wanted to talk about an area of quality engineering that has traditionally received much less attention than automation, CI/CD, or infrastructure, which is test data. Over the last several years, we have made tremendous progress in the quality software that can be built and tested. Pipelines are faster, automation is more secure, um, and environments are increasingly available on demand. But underneath all of that, many teams are still relying on test data progress that was designed for a much slower engineering model. So today's conversation is not simply about generating synthetic record faster. It's about rethinking test data as an intelligent engineering capability, one that can help us create the right data for the right scenario at the right time. Um, about me, I am Manideep Singireddy, Senior Manager SDET at Equinox. I have over 13 years of experience in enterprise quality engineering. My work has particularly focused on building automation across web, APIs, mobile application, microservices, and increasingly AI-enabled systems. I'm also passionate about mentoring engineers and sharing knowledge through conferences and meetups while helping drive quality engineering beyond traditional testing. A lot of the thinking in these presentations comes from seeing the same pattern repeatedly. Teams invested heavily in executing capability, but the data required to exercise those systems is still created manually. So I'm not approaching this as an engineering problem rather than an AI demonstration. Um, and the engineering problem becomes very viable when we compare the speed of our modern delivery systems with the speed of test automation. So let me ask you a question. AI has changed, but has your test data strategy? Um, Automation can run in minutes. CI/CD pipelines operate in minutes. Deployment can happen in minutes. Yet, getting the right test data can still take hours or sometimes days. That creates an interesting situation, right? We have optimized almost every stage of execution, but the input required to start the execution is still slow. So a regression suit may technically complete in like 20 minutes, for example, let's say. But if somebody has to spend hours finding details of the test data, maybe it could be related to accounts or adjusting records, coordinating with another teams, or refreshing databases before we run the test, then our execution time is not just 20 minutes, it is the entire time from test intent to usable data. And that gap becomes even more viable as we introduce AI assistant developments. AI can generate code, tests, and scenarios very quickly in this space. But if the underlying data progress remains static and minimal, then we have to think about it, right? So, why is it becoming urgent now? There are three changes happening at the same time. The first force is speed. Release cycles continues to shorten, which means test data provisioning has to become much more dynamic. The second is complexity. Enterprise applications are no longer one application talking to one database. A single customer journey may involve multiple APIs, event streams, identity platforms, external integrations, and several microservices, right? That means a valid test scenario may require a coordinated data state across many systems. The third force is AI. Traditional applications are largely deterministic. We provide an input, business logic runs, and we validate an output. But AI introduces prompts, context, retrieval knowledge, conversation history, and probabilistic responses. That means the data we need to test is no longer limited to the rows in the tables, right? So we have speed demanding faster data, complexity demanding richer data, and AI demanding context aware data. The three forces are converging at the same time, and that's why I believe test data can no longer be treated as simply something we provision before we run a test. Test data is becoming a strategic engineering capability. To understand why the existing model struggles with this, it helps to look at how enterprise test data has traditionally been managed. Um, this is the model many organizations still use today. Production data is copied, masked, moved into lower environment, and they consumed by the automation or for testing purposes. There are good historical reasons for this model. Production provides realistic relationship, realistic distributions, and realistic business states, right? But it also introduced several constraints. Um, Refreshes can be slow and it could be expensive. Access has to be carefully controlled. Masking becomes another operational process, right? So these tests becomes dependent on whether happens to execute in the copy data set. And more importantly, production reflects what already happened, right? It does not necessarily contain every scenario what we want to test. If I need a specific scenario combination of, for example, like a customer type, account status, a transaction, risk, and failure, finding that exact combination with all of these can be difficult. But the limitation is not simply that production data is inconvenient. It is that production first model makes it difficult to engineer coverage intentionally. And in many teams, the limitation shows up in several familiarities, like in day to day techniques, currently what we use, or some teams use it as this approach, like traditional data approach. We hard code test values because they are predictable. We build like small data generators or utilities for known scenarios. We put like SQL queries directly into the test code because it is the fastest way to prepare at a scale, right? And we manage data sets through spreadsheets and feed them into the automation. Each approach, all of these, solves an immediate problem, but over time, they create fragmentation, right? The business meaning of data comes from distributed across testing code, SQL queries, spreadsheets, framework utilities, and with individual engineer knowledge. So, this makes reuse difficult and maintenance is expensive. The issue is not that these techniques are wrong, The issue is that they do not provide a common intelligence layer capable of understanding what scenario is required. So that limitation becomes much more significant once the system under test starts using generative AI, which I'm going to share here. So this is one of the important changes to understand. In a traditional system, we can think of testing as an input, logic runs, and we get an output. We usually know the business rule and we can often predict exact what the output should be. But with generative AI applications, it's more complex. The input is no longer just user prompt. The response also be influenced by enterprise knowledge, conversion history, system instructions, and user context and model settings. All of these factors can change the answer, and even when the same input, the output may not be exactly the same when we run every single time. That means testing also has to change. We need to test what happens when the context changes, when a conversation continues across multiple turns. So the key shift here is we are no longer testing a single request. We are testing the full context around the request. And once we see this testing this way, we also need to rethink how what we can mean for the same thing for our test data as well. So traditionally, when we said test data, right, we usually meant it could be like customers, accounts, orders, payments, policies, or other structured business records, right? Those are all still important. But AI native application introduce another category of test assets: prompts, context, conversations, knowledge, memories, and adversarial scenarios. The change, the way we should think about the problem is a record tells us what data exists. A scenario tells us when situation we are trying to reproduce or what situation we are trying to reproduce. For example, a payment record by itself does not tell us whether we are testing insufficient funds, maybe fraud detection, a timed out, or a relay condition, right? Or unusual high risk transaction. The scenario gives the data meaning. That distinction becomes increasingly important as system becomes more dynamic, which leads to a more fundamental question again. Should we start with this question? What do we have? Or we search for the customer or an account or an order that approximately matches the test. What scenario do we need? A scenario driven model reverses the logic, right? We first describe the intent of the test. From the intent, we determine the scenario. Then we determine the exact data required to create that scenario. This may sound like a small change, but it is an important one. The scenario, rather than the existing data, becomes the starting point of the test. For example, I'll take the same example again. Suppose the request is test payment failure for high risk customer, let's say. Instead of searching through tables, hopping to find matching records, we first determine what the scenario should look like. Then we create or assemble the right customer, accounts, ring, and payment contribution. But for an AI to answer reason about this scenario correctly, it needs something, right? That generally purposes model does not automatically possess our enterprise context. So scenario becomes the unit of testing. So again, the architecture question. How does AI know what data is relevant? Does it magically know? No. AI language model or any understand does not understand the general concept of like customers, accounts, payments, nothing, right? But it does not understand what that concept means inside our organization unless we provide that information. It needs to know our data models, relationship, business rules, API contracts, and existing testing knowledge. For example, it may understand what an account is, but it does not know that in our platform, an account with a particular state cannot initiate a particular transaction, or that one API requires a relationship that exists in another system, right? This is where context became fundamental. The architecture should expose the relevant enterprise knowledge to the reasoning layer so that a request expressed in this business terms can be translated into a technical valid scenario. The flow on the slide represents the journey, right? Intent comes in, context informs the reasoning, a scenario is created. The appropriate data is generated, the test executes, and the results feed learning back into the process. The natural architecture question is then, if AI needs enterprise knowledge, should we simply give the model access to all of our databases? The answer is no. Giving the system more intelligent doesn't mean giving it unrestricted access, right? A safer and more scalable approach is to separate reasoning from data access. The LLM works with a context of metadata layer that explains the schemas, business rules, APIs, and relevant domain knowledge. When real data needs to be accessed or changed, that happens through controlled data services. So these services enforce the rules we already rely on, such as like permissions, read only asking, masking of sensitive data, auditing, and data correction. This this separation is important because an NLM is very good at understanding intent and planning what needs to happen. But access to database should remain and controlled. We do not want this model independently deciding what tables to query or what data to update, right? Instead, the model determines what it needs, and governed system determines how the request can be safely carried out. The result in an architecture this way, this gives us the benefit of AI intelligence without giving up security, governance, or operational control. Let's make that architecture more concrete by walking through one example from intent all the way to the usable test data. Suppose the test intent is validate high risk payment failure. That makes sense to a tester or a product owner, but it's still hard to broad to execute directly, right? The first step is to understand the context. So we may need details about the customer, what kind of customer it is, what account it is, what kind of payment, risk profile, and the business rules to determine when a payment should fail, right? So once we have that context, the reasoning layer can run the test request into a specific scenario. For example, a high valued payment risk from a high risk customer. This is expected to fail because of a particular business rule, right? Now we have to move from general testing goal to clear and repeatable scenarios. Only then we can create this synthetic data need to represent the scenario and send it to the system under test. The key change in the order is we are not generating random customers or payment data or hoping it is useful. The scenario defines exactly what the data needs to be created. So this leads to the sequence directly to a design principle that is easy to remember. I'll share here. So don't generate data first. Generative AI makes it very easy to create large amount of synthetic information, but volume does not improve testing. If you simply ask a model to create 10,000 customers or transactions or test users, we may end up thousands of records that represents essentially the same business condition. Instead, The first step we should be scenario generation. We identify the happy path, boundaries, failure conditions, risk conditions, and meaningful combinations we need to exercise first. Once the scenario set is defined, the data generation layer can produce exactly the records required for each case. This gives us much stronger relationship between coverage and data. We can trace a generated record back to the scenario. It supports and determines whether the important areas of the system remains untested, right? This is much more useful engineering model than measuring success of the quality of synthetic records. At the same time, we need to be careful not to just turn into an architecture where the LLM responds for every step. So the LLM should provide the intelligence, but it should not become the entire platform, right? So the system is understanding natural language requests, bringing together relevant context, reasoning through like possible scenarios, and creating a clear blueprint for what needs to happen. Once the blueprint is defined, deterministic systems should take over wherever possible. For example, a Python generator can create a million records more reliably than asking an LLM to generate them one by one. I can take another example where an API can create an account more safely than allowing the model to access the database directly. And a validation engine can also enforce schemas and business rules more consistently than asking the model to validate on its own, right? So the goal is to combine both of these approaches, use the LLM for reasoning and planning, and use the intelligence systems for execution and control. This division of responsibility becomes cleaner when we look at the test data factory itself. Intelligent test data factory begins with this scenario. Once we know the scenario we need, the system chooses the appropriate generator factory. Let's say, in some cases, direct generation by an AI model may be appropriate. For example, generating via natural language prompts or conversational context. For a large structured database sets, traditional tools such as Python, Java, whatever framework, internal libraries are useful faster, more reliable, and more predictable. And in many organizations, there are already many mature test data frameworks that know to create valid scenarios, accounts, orders through approved APIs. Or they might have built a Spring Boot service where they can fetch all of these data dynamically from an API, which calls the DB. So those capabilities should not be replaced. They should be reused and orchestrated. So the intelligent part of this factory is not simply generating the data, it is selecting the right generator based on these scenarios. So the output of this process is synthetic data, but synthetic data is not the same thing as reusable test data, right? We need to verify that it is technically valid and logically correct for the scenarios, which is why the next stage is probably the most important control in the entire design and validation. So it is very easy to demonstrate AI generating realistic looking test data. The difficult parts of guaranteeing that test data can actually be trusted. A generated customer record might look perfectly reasonable, but violate a schema. So all of these points we have to make sure: schemas, referral integrity, business rules, data distribution, scenario coverage. All of these must be approved. Once we generate and validate data reliably, the next question is whether the data should remain static or it should not. So the real opportunity comes when the system becomes a continuous feedback loop. Production signals shows what happened in the real world, right? Test execution shows that what are we covering and what things are aligned. And quality engineering helps us identify where defects are occurring or our coverage is weak or not. We can use those signals to create new scenarios, generate the right synthetic data, and run another round of testing. This means the test data evolves along with the application. For example, if a new customer behavior journey starts appearing in production, we can add that pattern to our test scenarios. If a defect exposes an edge case, we cannot test. So we can add that condition to the scenario library. So the test data is no longer a static asset. It becomes a continuous improving capability. And this feedback loop is the foundation for the most testing models we are looking at the next. So this architecture or the diagram brings the complete architecture together and shows how the ecosystem works with a continuous loop. Um, we start with the intent, what we are actually trying to validate. The context layer provides the enterprise knowledge needs to understand the request, including schemas, relationship, business rules, APIs, etc. And then the AI reasoning layer combines the intent and context to understand what needs to be tested. The AI scenario, the excuse me, the scenario engine then converts that reasoning into specific test conditions and a clear executable scenario. From there, a quality engineer intelligence helps determine what needs to be tested. Things like past defects, coverage gaps, signals, and previous test results. The test data factory takes the scenario and determines how the test should be executed, whether through APIs, user interface, or AI evaluations. Next is validation and governance. Make sure the required test conditions, controls, and data requirements are valid, safe, and compliant. The results are learning from the ecosystem feedback into future test intent. So helping us to create better scenarios, better test data over time. So the goal is not simply automate this test data generator. The goal is a closed loop test data ecosystem that continuously learns and improves. The key idea is that every part of this ecosystem improves the next and learning feedback into what we need to test. And if we build this, we need to prove that it is creating value rather than simply introducing new ecosystem, right? So for this strategy, the success metrics should stay practical, easy to measure. So the two metrics should go down. We want to reduce provisioning time. How long it takes us to get reusable test data into hands of testers. We also want to reduce production dependency. How much we rely on copying or masking production data just to create meaningful test conditions. At the same time, the next three metrics should go up. We want to increase scenario coverage so we can test more business conditions, edge cases, and risk conditions. We also want to increase reusability so the same scenario and data pattern can support multiple teams, applications, and test layers. And most importantly, we wanted to increase defect detection, especially defects that our current test system data approach which are missing. So these measures keeps the strategy focused on the real quality outcomes. Generating large volume of synthetic data is not the goal by itself. We want to create millions of records, but provisioning it is still slow. Production dependent remains higher. So the overall objective is simple: reduce the required effort to get a quality test data while increasing the coverage, reuse, and defect detection. Ultimately, faster access is the right test data helps us achieve faster and better quality outcomes. So good news is the organizations do not need to build this ecosystem like whatever I presented in day one. So the progression on this slide is intentionally incremental. Start with metadata because the system cannot reason about enterprise data. It does not understand. Build visibility into schemas, APIs, and business rules. Next, introduce synthetic data in areas where production dependency creates clear. Once those foundations are stable, use GenAI to help generate scenarios rather than immediately handing the operational control. Add governance and validation so generated outputs can be trusted. From there, agentic workflow can begin orchestrating individual steps such as understanding the request, selecting a generator, validating the output, and triggering automation. So these behaviors should be the final stage after the underlying controls are mature enough to support a continuous learning loop. So, this allows teams to create value at each stage rather than waiting for a large transformation program to finish. So, if we reduce the entire journey into small number of concepts, these are five shifts worth remembering. The first shift is from production first to synthetic first. Production data may still have a role, but it should not be longer the default answer to each testing requirement, right? The second is from records to scenarios. The business situation we need to reproduce becomes more important than simply finding a dataset. The third is static data to data intelligence, where context, relationships, and usage becomes part of the system. The fourth is from manual provisioning towards agentic, where repetitive works can be coordinated automatically while remain governed. And the final shift is from test data management as a standalone function to an autonomous ecosystem that connects intent, intelligence, generation, validation, execution, and learning. These are not five just separate initiatives, these are stages of the same evolution. So, for a long time, test data was treated as something that supported testing. We designed a test, found some records, prepared an environment, and then executed automation. In this model, we have discussed today, the relationship changes. We begin with the intent. Intelligence interprets the intent using enterprise context. Scenarios define what needs to be exercised. Data is created specifically to represent those scenarios. And so the test data no longer just an input sitting underneath automation. So it becomes one of the mechanisms that actively drives coverage and quality. That is the larger opportunity created by GenAI. So for decades, test data supported testing. In the generative AI era, test data will drive the testing. All right, thank you.
Thank you so much, Manideep. That was a genuinely insightful session. And I think we are ready for some questions now. I can see some of them queued up already. So we can start with them. Okay. Okay. If AI can generate infinite test data, how do we decide which data actually matters?
Um, what? Sorry, what I missed the question.
Yeah.
If
Yep.
AI can
Okay.
generate
Mhm.
infinite test data, how do we decide which data layer matters? Yes. So for this question, we have to have the governance layer, right? So that decides where which data actually matters, but it cannot be useful for you, right? The same data cannot be useful. It can generate like hundreds of records. Let's say you might use a test card that cannot be validated, right? So you have to have a validation points in between to make sure.
All right. Okay. We can move on to the next one. Okay, so here's another one. Does Gen AI created data fully solve the privacy problem or just move it?
Does GenAI generated data fully solve the privacy problem or just move it? Not fully, for sure. Just move it. Yeah.
Okay, let's move on to the next one. Okay. How do you prevent defects from happening?
Um,
Right.
it's a very hard question. It's we can defects are predictable. As a QA, I wanted to find a defect first. Like that's my first job, right? So yeah, it's hard to find, but we can prevent it based on like from the automation, like false tests, right? So sometimes like the automation test might fail because of the test data, or so then again you would log it as a ticket, right? So then those are like all these false defects.
Okay. Yeah, moving on to the next one. From the strategic perspective, how often should test data be updated to stop model drift?
um can you come again? Sorry, what was
Yeah,
that?
okay, so I'll repeat it. From the strategic perspective, how often should test data be updated to stop model drift?
From the strategic perspective, how often should test data be updated to stop model draft? How often should test data be updated to stop model drift? Yes, for this, it should it shouldn't be frequent. It shouldn't be frequent.
Okay, I think we can close the Q&A session now. That was all. Thank you, Manideep. Thank you so much. It was great having you and hosting this session with you. The key takeaways from the session: test data is one of those problems everyone deals with and few people talk about. So
Yeah,
it's great to see a practical way to rethink it with AI without giving up on governance.
yeah.
So thank you so much for being here with us. And thank you to everyone who joined and shared your questions. If this sparked ideas for your own test data strategy, that's exactly the point of the session. So take one of them back to your team. Also, we'll be uploading a recorded video of this session on our YouTube channel. So that's it from us for this session. Enjoy the rest of the conference. Thank you so much.
Thank you.
Bye bye.
Thanks, everyone.